A point AB is chosen at random in the interior of the square with these 4 vertices. So let's draw that. So here we've got -5 and +5, -5, +5. So we've got a square right here. Let's close that square off. There we go. Now, we want to determine the probability that the absolute value of A plus the absolute value of B is greater than or equal to 8. Now, let's consider the endpoints. These endpoints are going to fit. But where on the edges? Will it work here? Well, no, because this point is 0, 5. That's not going to fit this inequality. So that means I have to go over 3. Let's make that a little smaller. 3, 5, but then also -3, 5. Now, that's also going to work down here because since there's absolute value on both of them, it's not going to matter whether we have positives or negatives. So -3, -5, and 3, -5. And then over here we have 5, 3, 5, -3. And then over here we have -5, 3. And then we have -5, -3. So these regions right here make up the regions that fit this inequality right there. Because if I take the x and y values in here, take their absolute value, they're going to add up to at least 8. Anything in here, the absolute value is going to be less than that. When the absolute value of the two x and y values added together will be less than 8. So the question is, what is the probability that the points land in here? Well, we use area. So the area of the square well, let's see. We go 10 this way and 10 up and down. So that means the area of the square is 100. So here we have the area of the triangles. So we've got a 2 and a 2, a 2 and a 2. So that means each of these triangles has an area of 2, 1/2 base times height. But we've got 4 of them, so we get 8. So our probability is 8 out of 100, and that reduces to 2 out of 25.